All right, so let's take a look at some examples. So here we want to select which one of these in these sets has the higher melting point and boiling point and explain why. So you probably want to go ahead and pause the video here and go through this yourself. All right, so hopefully you've done that. Let's take a look at what's going on here. Water H2O, we know this has hydrogen bonding and it's also polar, so it's got dipole-dipole interactions. This compound right here does actually have lone pairs there, and so it is actually polar, so it does have dipole-dipole forces. We know that hydrogen bonding, however, is the strongest intermolecular force, and the one on the right does not have hydrogen bonding, right? There's no OH bond. Remember, each one of these right here is a CH3, and this is another CH3, right? There's no direct OH bond. And so hydrogen bonding is the strongest intermolecular force, so it's going to have the highest melting and boiling point. It's going to take the most amount of energy to break those apart. And just to give you some numbers, the boiling point here for water is 100 degrees Celsius, while here for dimethyl ether, it's negative 24 degrees Celsius. So you can see quite a big difference there. In this next compound over here, we only see carbons, right? These are all carbons here. And so we know this is nonpolar, and so it doesn't have any dipole-dipole interaction. So all this has is LDF, so it's probably not going to have a very high boiling point. Whereas in this one does have a dipole, right? There's an oxygen carbon bond, so this molecule is polar, and so this one does have dipole-dipole forces, as well as LDFs. Everything has LDFs, right? So this one has dipole-dipole forces, so it has the stronger intermolecular forces, and thus the harder to break apart, and thus the higher boiling point, right? This one's negative 7 degrees Celsius, and this one is 58 degrees Celsius. Next up, we have these two carbon-based molecules. They're both 4 carbons, and so they look overall pretty similar. So they both only have LDFs, and they're both approximately the same size. If you look at the formula for both of them is actually exactly the same. And so size isn't a factor here, but what is a factor is the surface area, right? This one's got more surface area, so it's got more or stronger LDFs. And so it will have the stronger intermolecular forces and it'll have the higher boiling point. This one's negative 1 degree Celsius. This one's negative 12 degrees Celsius. So you can see they both have pretty low boiling points, but one is definitely higher than the other, right? So these problems are pretty good because you need to be able to look at these structures, right? These skeletal structures, think about what the compound actually looks like, figure out what the polarity is there hydrogen bonding, and then use that information to determine the properties of the compound.